In today's lesson, we are continuing with the concept of graphing linear relations. The examples that we look at today are going to look familiar because these are questions that you've actually worked on in assignment number 1. So recapping what we have learned so far. An equation in two variables, meaning an equation that has both an x and a y variable, has an infinite number of solutions, and those solutions are called ordered pairs. They are of the form x comma y. We can then take those ordered pairs and organize them in a table of values, and from there we can then graph the relation on a Cartesian grid to see what the relation looks like graphically. Once we have a set of ordered pairs and a graph, we can then calculate the slope of a line. And in last week's lessons, you looked at calculating the slope using rise over run, rise being your vertical up and down, and the run being forwards and backwards. As well, if you are given ordered pairs, there is a formula that you can use, which is the change in the y values, which is equal to the rise, over the change in the x values, which is equal to the run. So today we're going to recap these different concepts using examples that we've looked at before, and we're going to add in some extra terminology. So last week on assignment number 1, you were given this equation, this relation, 3x plus 2y equals 12. Okay. And you had to complete the table of values. Now I've added a couple extra rows. So what happens is if x is equal to 6, we replace x with 6 in the equation. So it becomes 3 brackets 6 plus 2y equals 12. And then we have an equation with one variable, and we proceed to isolate for y. So 3 times 6 is 18, and it transposes to the other side, and it becomes subtract 18. So we have 2y equals negative 6. So y equals negative 3. So you should have negative 3. And if y is equal to 0, x is equal to 4. If y is equal to 4, we are going to get a fraction for x. It's going to equal 4 over 3. If x is equal to negative 1, we are also going to get a fraction. We're going to get 15 over 2. And if x is equal to 0, y is equal to 6. So I want to highlight these two rows because in these two sets of ordered pairs, either x is equal to 0 or y is equal to 0. And we're going to look at those specific points on our graph in just a minute. So what we need to do is we actually have to take these ordered pairs and we are going to graph them. So the first thing we're going to do is we're going to go over to 6. We're going to move over to negative, so we have to go to positive 6 on the x-axis and down 3. 1, 2, 3. There's our first point. Our next point is 4, 0. 1, 2, 3, 4 on the x-axis, and our y-coordinate is 0. Now the next one here, this is a little bit tricky because 4 over thirds is not a whole number. But I know that that is approximately 1 1/3 or 1.3 as a decimal. So I'm going to approximate that. I'm going to go to 1 and just past 1, and then I'm going to go up to a 4, positive 4. I'm going to plot my point, and then I'm going to continue. Negative 1. Oh, I've got another fraction. But 15.2 is equivalent to 7.5. So I'm going to go negative 1. There's positive 7, and halfway between 7 and 8 is 7.5. So I'm going to plot that point. And then I'm going to continue. When x is equal to 0, the corresponding y value is 6. So I'm going to pull out my point. So this is what we need to do. We need to get out a ruler, and I want to verify that my points line up to create a straight line. Okay. And there we go. They do line up to form a straight line. You need this to happen when you have a relation in two variables. For our purposes, the points are always going to line up to give us a straight line. So we can now connect these points together. Line them up, and I'm going to put an arrow on each end to show that this line continues in each direction. So the numbers for x can decrease, and also the numbers in this direction, the y values can increase, and we are going to have the line continuing. We want to be able to calculate the slope of this line. So we can use any 2 points from our graph, or we can use the formula y2 minus y1 over x2 minus x1. I'm going to use the 2 points. So I want to find 2 points that I can identify very clearly. So if I highlight here in red, we can kind of draw in a right triangle, and it's not showing up very well there. Okay, so to go from this point here to this point here, this is where I wanted to find my slope. So I had to go down 6. So my slope, I'm going down 6, and then I go forward 1, 2, 3, 4. So my run is positive 4. So my slope is negative 6 over 4, and I reduce that to lowest terms to get negative 3 over 2. And that makes sense because this line is going downwards. It has a negative slope. Now, I've also circled these 2 key points. That was just a coincidence. This point up here, the point is on the y-axis. So this point is called the Y-intercept. And this point down here is on the x-axis. And so the point where your line crosses your x-axis is called the x-intercept. Okay, and we're just going to summarize that. The x-intercept happens when x is equal to 4, and the y-intercept happens when our y value is equal to positive 6. So your x and y-intercepts are just numbers, but they do correspond to locations of ordered pairs. Our next example is x plus y equals 15. So again, like last week, we're going to substitute y is equal to 2 into this expression. That will give us 10. So our y value 2 gives us an x partner of 5. And we're going to insert x is 0 here. This is new. We're going to add this piece in. If x is equal to 0, y will equal positive 3. And if y is equal to 4, we're replacing y in this equation with 4. 5 times 4 is 20. We transpose that and take it away from 15 to get negative 5. And when x is equal to negative 3, the negative 3 is replaced here. It transposes and it becomes positive 3. So it's 3 plus 15 to give us 18. And we divide that by 5. So this will be 18 over 5. And the other new piece we've added on is when y is equal to 0. When y is equal to 0, you replace that in your equation there, and you proceed to solve that x is equal to 15. So now what we're going to do is we're going to take all these ordered pairs and we are going to graph them on the same grid just to save some space. So the first point, ordered pair is 5, 2. So there's over to positive 5 and up to 2. Here's our first point, 0 and 3. So x is 0 up to 3. Negative 5 up to 4. And this one is tricky 18 over 5, we are going to convert that to a decimal. It's 3.6. So we're going to go to -3 and up to 1, 2, 3, and just past the halfway point. There's our point. Now this is also tricky because when y is equal to 0, my y value has to be 15, which is off my grid. So for now, I'm just going to leave that. But I want to make sure that this is in fact a linear relation. So I'm going to get out my ruler once again, and I'm going to line up the points. And they do line up nicely. And I add my arrows. And this gives me confidence that I have done my calculations in my table of values to get my ordered pairs correctly. Now to calculate the slope, again, you can use any points on your graph. This one here works really well because it's there's no decimals, and I can also use this point here. So I'm going to draw in my right triangle, and I'm going to work with my slope. So I had to count down 1, and I had to go forward 1, 2, 3, 4, 5. So I went forward 5, so my slope is -1 over 5. That makes sense because this has a negative slope. Another way to calculate the slope is to use the formula. So if I want to use the formula, I'm going to go back and use the y2 over y1. Pick any 2 points from your list of ordered pairs. So let's pick the x and y intercepts. So I'm going to use the point 0, 3 and the point 15 over 15, 0. So the slope will be I need the y value. So it'd be 0, take away 3 over 3, 0 take away 3, 15 minus 0. So this becomes -3 over 5. -3 over 15, and that reduces to -1 over 5, which gives us the same answer we found the other way. So there are 2 ways to find the slope, using 2 points from your graph or using any 2 ordered pairs. If you're doing the calculations, be strategic and pick ordered pairs that don't have fractions. Not always, but if you can, to minimize your calculations. So the x-intercept occurs when our graph crosses the x-axis. We can't see it, but we know that when the line crosses the x-axis, the corresponding y value is 0. So that means this point here is the x-intercept. The x-intercept occurs when our x value is 15, and the y-intercept is when our graph crosses the y-axis, and it crosses the y-axis at 3. So the y-intercept is +3. To summarize the new concepts, the x-intercept is the x-coordinate of the point where the relation, in our case, it's a straight line, intersects the x-axis. At this point, the corresponding y-coordinate has a value of 0. The y-intercept is where the y-coordinate of the point intersects the y-axis. When you intersect the y-axis, the corresponding x value is 0. To practice these concepts, you're going to go back to assignment number 1 and follow the instructions listed below.